Hi, good evening, students. In previous video, we will discuss the drift velocity and expression for drift velocity, relaxation time, and mobility of free electrons is discussed, and also discussed the derivation of drift velocity, and also discussed the expression for current in terms of drift velocity of the free electrons is discussed. Dear students, once again I am recapping that thing. First term yesterday in this video we are discussed is drift velocity. Students, what will happen? For example, one conductor is there. In this conductor, for example, this is metallic wire. If this metallic wire is applied to some potential difference is applied to this metallic wire means what will happen means a number of free electrons are there. These free electrons will be drifted in the direction of opposite to the electric field, and this drifting of electrons will gives the drift velocity. And simply we can say here number of free electrons are there. So in definition we can write drift velocity means average velocity with which these free electrons drift in a metallic wire when a potential difference is applied across its ends is called as drift velocity. And expression for drift velocity is also discussed, and expression for drift velocity means we know already vd equal to drift velocity equal to minus small e capital E tau divided by m. This is the expression for drift velocity. Here minus sign indicate that electric field E and drift velocity Vd, these two are in opposite directions, and small e means charge on the electron, and tau means here relaxation time. Tau is nothing but relaxation time, and m means mass of the electrons. Okay, this students, this is discussed in previous class. Drift velocity means the average velocity with which an electron drift in a metallic wire when a potential difference is applied across its ends is called as drift velocity. And expression for drift velocity is also discussed, and one more term is discussed, that is mobility. Mobility means a drift velocity per unit electric field is called as mobility, right? Drift velocity per unit electric field is called as mobility, and SI unit of mobility is a meter square per volt second, meter square per volt second. Now one more term is also discussed in previous class, that is relaxation time. Relaxation time, that is denoted as tau. Relaxation term is denoted as tau. And what is relaxation time means what will happens. For example, this is the conductor. In this conductor free electrons are drifting. Okay, number of free electrons will move in a different directions. They will move in different directions, and when potential difference is applied means these free electrons, number of free electrons available, these free electrons will collide with each other. Collision of two electrons or more than two electrons will take place after successive collision. After successive collision with a fixed ions or positive ions in a metal, they will take some time rest, and they will take rest or relaxation will takes place. So that we can define relaxation time means the average time interval between two successive collision of electron with fixed ions or fixed positive ions are called as relaxation time. So these are the three cases were discussed in previous class, and also discussed in previous video what are the relation between current and drift velocity. I means current and drift velocity means Vd, and how the drift velocity and current is related means small n capital A and small e into Vd. Okay, this is the relation between current and drift velocity. Once again I am writing this one in simply we can remember this one. Drift current equal to n small e a capital Vd. This is the relation between drift velocity and current, right? Current and drift velocity. N means here, what is the N? N is nothing but here number of free electrons per unit volume of the conductor. Small n means number of free electrons per unit volume of the conductor. E means charge on the uh, electron, and A means area of cross section, and Vd means drift velocity, right? And this is the relation between current and drift velocity. This is also discussed, and one more term is discussed, that is conductivity is also discussed in previous case. What is conductivity means? Reciprocal of resistivity will use the conductivity, and SI unit of conductivity is per ohm per meter. Now we'll discuss one more relation is there, relation between current density and conductivity. Okay, to discuss that relation, we know already current density. Current density is denoted as J. Current density is denoted as J, and also conductivity is denoted as sigma. Conductivity is denoted as sigma, and the relation between these two means J equal to sigma into vector E. Sigma into vector E. This is the relation. J means conductivity. Reciprocal of resistivity will use the conductivity is denoted as J. Sigma means conductivity, right? Reciprocal of resistance will use the uh, reciprocal of resistivity. Reciprocal of resistivity will use the conductivity, that is denoted as sigma. And E means electric field. Okay, this is the relation, J equal to sigma into E. J means conductivity, and rho means conductivity. J means and E means E means electric field, right? Now I'll discuss what is the relation between these two, right? So the students, to discuss this one, and question is asked in this way, the question is displayed here. Derive an expression for conductivity of a material in terms of relaxation time. Sorry students, uh, that is discussed, okay, sorry, conductivity, sigma equal to, conductivity means sigma equal to ne square tau divided by m. This is the relation between relaxation time and conductivity. This is the conductivity, and this is tau is relaxation time. Okay, actually we need to derive this formula, sorry. Okay, I will discuss this one. This is the relation between conductivity of a material in terms of relaxation time, right? To prove this one, actually we need to prove the one more before that I am discussed this one. Okay, we will discuss this first, and after that we go for next relation, right? Now I will discuss this thing, deriving relation between current density and conductivity of a conductor. Or simply they may ask this question, J equal to sigma into E, right? J means conductivity, E means electric field, and sigma means current density. J means current per unit volume is called as current density. Current per unit volume is called as current density. And conductivity means reciprocal of resistivity, that gives conductivity, right? Okay, just it is confused. Now I am discussing these things. We'll discuss important derivation is there. Derivation is not asked in your examination directly. They may ask write the expression for current density and conductivity, they may ask. Okay, we'll derive this one relation. Okay, to derive the current density, okay, in figure it is already there. L means, okay, this is the L. This L is called as the length of the cylindrical metallic wire. This is the cylindrical metallic wire, and L is the length of the cylindrical metallic wire. And A means area of cross section of the wire. Here A means area of cross section of the wire. Okay, I am indicating this A. This is the A means area of cross section of the wire. And this V means potential difference is applied across these two ends of the conductor. And E means electric field set up in the wire. And Vd means drift velocity. E means charge on the electron. and I amount of current is flowing in this wire. Now V means potential difference applied across the conductor or metallic wire, I means current flowing through the wire, L means length of the cylindrical wire, A means electric field set up in the metallic wire, capital A means area of cross section of the wire. Now, by definition, we know already current means by using Ohm's law, we have Ohm's law V equal to IR. This implies I equal to V divided by R. This is the equation 1. Students, we know already resistance R we can write rho L divided by A. Right? We know already resistance is directly proportional to length and inversely proportional to area. This proportionality constant will give the resistivity. So R equal to rho L divided by 1, and substituting this value R value in equation 1 here, rho L divided by R. I equal to V divided by R is there, V divided by R. R means this term is here, and this becomes this denominator goes to numerator, and V into A divided by rho L. Right, now we'll discuss what will happens. I is there, I am taking this V. Again discussing this one, very simple derivation is there, we'll discuss this one. Now see, I am taking this A this side, right, this A this side, and I divided by A equal to 1 divided by rho, 1 divided by rho, and V divided by L. Okay, actually equation is like this, I equal to VA divided by rho into L, and this A I am taking this side, so I divided by A, which is equal to 1 divided by rho, and remaining V divided by L. Okay, now we'll discuss what will happens. This is equation 2, right? Now, but current density means we know already, current per unit area that gives the current density, current per unit area that gives the current density, and electric field means potential difference per unit length that gives the electric field E, and 1 by rho reciprocal of resistivity will give the conductivity. So using these three terms, okay, I divided by A means J, I divided by A, this term is J, 1 divided by rho is sigma, 1 divided by rho is sigma, and V divided by L is E. So J equal to sigma into E. So final answer is J equal to sigma into E. Okay, this is the very important derivation, J equal to sigma into V. J means current density. Current density means current per unit area is called as current density, and electric field means the potential difference per unit length that gives the electric field, and the reciprocal of resistivity will give the conductivity. Hence the relation between current density and conductivity is this one, J equal to sigma into E. In the above relation, R means resistance of the wire, and J means current density, rho means resistivity of the material of the wire, and sigma means conductivity of the wire. This is the simple. So the students derivation is not asked, only just to remember these things. All right. Okay, next we move on to the second derivation, right, of this chapter, and after that we will stop the video because a lengthy video will takes place, so that I am only deriving two formulas only. Okay, now we'll discuss one more relation is there, expression for conductivity of a material in terms of relaxation time. Sometimes the question may ask like this. Okay, here we know already, sigma means conductivity, and tau means relaxation time. So the relation between conductivity of material, relation between conductivity and relaxation time, sigma equal to N square tau divided by M. To derive this one, okay, in diagram it is there. Again same thing is there, this is L. L means length of the cylindrical wire, A means area of cross section of the wire, E means electric field set up in the wire, and I means current flowing through the wire, Vd means drift velocity, and V means potential difference applied across the ends of the conductor. Okay, again this is same thing is there. Now we discuss how to derive the above formula. Okay students, just only we proved that J equal to sigma into V. This is just we proved this one, right? And this is proved J equal to sigma into E, and sigma equal to means J divided by V. Sigma equal to means J divided by V, right? Okay, sigma equal to J divided by E, but J means current per unit area. We know already. Conductivity means, sorry, current density means J, it is denoted as J means I divided by A. So the sigma equal to this J value is substituted here, I divided by A into E. But we know the relation between current and drift velocity. This is the relation between current and drift velocity. I means this value, I means NAEVD is there, and substituting this, and sigma becomes this term NAVDE divided by A into A, and this A get cancelled, and remaining terms are, what are the remaining terms are here? Only the things are this one. Okay, A get cancelled, this A and this A get cancelled, and sigma equal to N VD E divided by capital E. But we know already relation of drift velocity, small e capital E tau divided by M, and minus sign is not there. Minus sign only indicate that VD and E are opposite, and substituting this value VD value in equation, and sigma equal to this one N into N, and this E divided by capital E, and using this relation here, putting this relation, E small e tau divided by M, and E get cancel, and E into E square, N is there, N E square tau divided by N. Okay, this is the final relation, conductivity of material in terms of relaxation time, sigma equal to N E square tau divided by N. So the students, I think this derivation is very simple. In the above relation, suppose this question is asked for 2 marks, means directly we can write this relation, conductivity and relaxation time, relation between conductivity and relaxation time, sigma equal to Ne square tau divided by M. J means your current density, once again I am telling, and sigma means the conductivity of the wire, and N means number of electrons per unit volume of the conductor, tau means relaxation time, and E means charge on the electron, and M means mass on the electron. So the students, I think both the derivations you are having clear about it. So I we will discuss next topic on tomorrow videos. Thank you for watching this video. Students, those who are not subscribed this channels, please subscribe the channel, because I am continuously making videos on the second PVC complete syllabus. If possible means I will do all the chapters. Thank you for watching. Thank you. Bye bye.